Hi everyone. Now I'm going to talk about session 4.1, the exponential functions. So the exponential function is a function that in the form as fx equal to b to the power x, where b had to be greater than 0 and b cannot equal to 1. Remember that in this form, x is a variable which is on the exponent of the function. So this is called exponential function. Okay. Let's compare algebraic function with exponential function. In here, I have two forms. The left-hand side is algebraic function with power function. So you see that it is fx equal to x to the power b. In here, the variable is at the base, okay? And the top is like a constant number, right? And in the right-hand side, you have I have exponential function. Fx equal to b to the power x. And in this case, base, in here, b is base, right? And it's a constant, okay? Constant. And the top is x, is a variable, okay? So now, let's try to identify the function as algebraic or exponential. Okay, so let's take a look at this example. I have A, B, C, D. Let's see which one is algebraic and which one is exponential. For the problem A, you see that the base of this function is having variable with x, right? You see that the base is here, right? So you and when you see the exponent of this function, you see that it is -7, which is a constant. So so you can right away say, oh, this is algebraic. Okay, algebraic function. Now let's move to B. You see that B equal to f equal to 5 to power 3x. So you see that B is in here, or base in here equal to B, which is equal to 5. And it's greater than 0 and not equal to 1. Okay, so you can just let me have the not equal to. Okay, you can just right away say this is exponential function, and power is 3x variable. So this is exponential function. Okay. Come to problem part C here. I have the base at the -5 and power is variable 3x. So look like this one may be an exponential function, but actually not, because why? I have b in here equal to negative, or base in here is equal to -5, but this is less than 0. And in the requirement of the exponential function, b had to be greater than 0, or b cannot be a negative number. So it is algebraic, or you can say it is not exponential function. So it is algebraic. Okay. um, I would change it to be, it is not an exponential, because uh, because this is like an special case with neither algebraic and neither exponential. So I would like to say is not an exponential. Okay. So come down to D here. You have f equal to 1 to the power x, and in here, right where you see that base is equal to 1, which is not specifying the requirement for the exponential function, that we cannot equal to 1. And now I can rewrite fx to be equal to 1, because why? 1 to power anything's wanna be equal to 1, right? So say 1x equal to 1. So this is I can say it is not an exponential function, or I can even say it is an algebra. Well, this is algebra. Algebraic. Okay. Okay. All right. So now I'm going to talk about growth or decay function. So let's do an example. I would like to graph function fx equal to 2x and gx equal to 1/2 of x. Okay, so I want to see how it look like, how the graph look like, and then I'm gonna make a decision to say is that growing or is that decaying. So I would like to have a t-table in here with x value, and the right hand side going to be fx and gx value. Okay, and I put several number for the x, say -3, -2, -1, 0, 1, 2, 3, and I will have value of fx will be 1, 8, 1, 4, 1, 2, 102, 1, 1 and 2 and 4 and 8. Similarly, for g of x, I will have 8, 4, 2, 1, 1/2, 1, 4, 1 over 8. So it's look like um, uh, the increasing of x will get the increasing of lx, but inversely, the increasing of x will give me the decreasing of g of x. So you see that, right? Now so according to this table, I can graph the function of fx and gx look like in the right hand side over here. You can see that the fx is going up from the y value is lower. It's look like coming to 0, but it's going up quickly, go to infinity. And in the other hand side for g of x, it's going decreasing. It keep going down and try to reach to 0 for the y value. Okay, so I would like to say if b is greater than 1, the increase as x increase, this function refer to grow to as a growth function. Okay, so b greater than 1 will give you a growth function. Okay, for the exponential function. Okay. In another case, you will have b, the base is between 0 and 1. So in the example is it is like in the example it is base is equal to 1/2. So it is 0.5 and is in between 0 and 1. So it's gonna give me decrease as x increase. So what does it mean? The y value will decrease as x increase, right? And the function refer to decay function, okay? So let's have another example, okay? In example 2 here, I want you to identify it as a grow or decay function. So fx equal to 10 to the power 2x. So I will actually just gonna check the base. In here is 10. So I will say since b equal to 10, I have changed this b, which is greater than 1. So this is a grow function. Okay. Remember that the actually in the form as fx equal to b to the power x already. So the power in here is not like a negative number. So I mean negative of x or something. So I want to make sure that you know that it is like a the variable, I mean the power is 2 of x. So that's similar with the general form of the exponential function. So that's give me and because the base is greater than 1, then this is a growth function. Okay, for part B, I have b equal to 0.02, which is less than 1 and greater than 0. So this is a decay function. Okay? Easily. Because why? Because base in here is greater than 0 and less than 1. Okay? So now I would like to talk about the number e, or natural number. If you still remember in correct algebra, you have learned number e already. And at that time, I or your professor have some like general definition for you. So number e is like similar like a constant number, like a pi, you know. It is an irrational number. So is defined as at the formula here, which is limits of 1 plus 1 over x to power x when x go to infinity. Okay, so when you try to have that number e, you can use a calculator, or I mean you can use the number approximately is 2.718 something else, but I usually just use only 3 digits. So that's the e, and we will see the natural exponential function such as fx equal to e to power x in this section. Okay. Okay. And what is application of the exponential function? Let's talk about the, in business, what the application from exponential function to the business is. We'll talk about investment. In example 3 here, is talk about how to invest some money and how to understand interest rate from the from the bank or from somewhere that's talk about interest rate. Okay. So in this formula, so I'm gonna copy this one. Actually, I didn't explain everything here already, so I don't want to even have to say it. So AT equal to P times 1 plus R for N over N power NT. And you're gonna say, oh, what's the AT, what's the P, and what's R, and what's the N? So I would like to say P is initial amount or particular amount here. Okay, so let me. Oh, what happened? Once again. So so like when you go to the bank, you want to invest something, right? You will have to see how much money you have. That is the money, the initial money you have is P. So let me see. What happened? I don't know what happened with my pen. All right. I think that's good now. Okay. And P is like a particular amount of money or principal. Okay. And the R in here is interest rate. Okay. I would like to add something for this. Interest rate in decimal number. Okay. So in decimal. So you will not use, maybe they give you like a interest rate in percent, but you have to change it in become decimal. And N is a compounded time per year. Okay, compounded time per years. Okay, and lastly, A is a money accumulate after T years. Okay, so after T years, how much you get for the A? Okay? So this will change. This formula will change if you have compound in continuously. Okay, and it's become the form as AT equal to P times E to power RT. So for A and P going to be similar with notation from the other formula. Okay, but the thing in here is how can you when and how can you apply weak form in these two forms? So let's do this example. They want you to route it to the nearest cent and find the amount of money accumulated 2,500 is invest. So this is initial invest, right? It is P for 3 years. So 3 years is T equal to 3, right? Okay. And at 5% interest. So you should know that interest is 5%, and you have to change this become decimal is 0.05. Okay, so now let's talk about case A, quarterly. And it is, I mean, quarterly, what does it mean? Here is actually, I want to tell you that is, it compounded quarterly. Okay, compounded quarterly mean that compounded quarterly mean that it's compound how many times a year? 4 times. Compound 4 times a year, right? So n in here equal to 4, right? And I'm gonna apply the first one, the first form, because this clearly tell me how many time, how many time you compound a years. So I'm gonna apply this form. Okay, at equal to p times 1 plus r to the power nt. Okay, so let me plug in. So plug in, put n equal to 4, p equal to 2,500, t equal to 3, and r equal to 0.05. Did I miss anything else? No, right? So I have p equal to 500, r equal to 0.05, n is 4, and this n 4 multiplied by 3. Okay, so in order to do this, you need to know how to do calculator. Okay, so let me show you to use calculator. I'm going to use TI-83. So let me see. Where's my TI-83? Give me 1 second. TI-83. So here we go. Oh. And I don't know, but it say that I cannot get in. Okay, now I get in. Let me see. I'm gonna share you my calculator. So screen. Okay. Here we go. So let me clear everything. Okay. So now I'm gonna use my calculator to calculate this case. So I have 2,500 times, I have to put parentheses 1 plus 0.05, and then divide by 4, close the parentheses, and then power 4 times 3. You can put right away is 12, right? So then you're gonna enter and get 2901, which is answer equal to 2901 point, because it's round. it say it want us to round to the nearest cent, so I need 2 more decimal number. So 89. Okay, so 88 for 86, so 89. That's right. So that is amount that you will get after 3 years with compounded quarterly. Okay, so okay. Now let me how about for the monthly? Okay, for the monthly, you should know that it is. Let me copy this down. Compounded monthly mean that's compounded how many times per year? 12 times, right? And you're gonna plug everything the same, but n is changing. So n equal to 12, and you're gonna copy down this. And I change this 12, and this 4 become 12, and similarly, I should have the number as 2903.68. 2968. Okay. So so that is for monthly. What about daily? Okay, daily. What does that mean? I'm gonna copy this down. So here is clearly tell me assuming there's 365 days in a year. So it should be compounded daily mean that is compound 365 times a year, right? So I'm gonna change and become 365, and the number that I should put in here also change, gonna be 365, and 12 become 365, and the money will be, if you use calculator, you will get 2904.56. Try to practice on the calculator, okay? I just show you one time, so you should know how to do. And lastly, continuously, you don't know how many times you compound in a years. So it actually is gonna be this form, okay? Or E number, all right? And now you will change two five zero zero multiplied by E. Let's put E here to power. What's R in here? 0.05 time with the T, which is 3. And for this one, it should be equal to 29404.59. And yeah, and that's it. If you want to compare between all the case in here, you're going to see that the more compounded, the more money you get. So for the continuously, you will get the highest amount of money after 3 years, which is $2,904.50. Okay, I have finished section 4.1. I would like to say you should do your homework, your assignment 4.1 on XYZ as soon as possible. Don't mess up with that. Okay. I see you on 4.2 later. Bye.